Okay, so kind of getting to where we were headed with this, at least one of the places that we were headed, we're going to use what we just worked on with the factoring of equations in quadratic form, or the factoring out common factor, to solve some more complex looking equations. So the first one we have is a fourth degree. We know how to solve quadratics, but a lot of us probably haven't worked on fourth degree. However, if it's factorable, we can use the exact same rule. And the rule is that if you multiply two numbers and you get 0, one of those two numbers or both had to be 0. So if we can rewrite this as a product that's equal to 0, 0 is the key piece of information there, we can then claim that either one or both of those factors had to equal 0 to make a true statement. Okay, so let's work on the factoring piece. And again, feel free to use your substitution if you prefer that. What I'm seeing here is that x to the fourth is like x squared squared. So I can split those x squareds up. And again, we had a 4 earlier. I can choose 2 and 2, or I can choose 1 and 4. I'm seeing that 5 for my last two spots in the parentheses, and I'm thinking 4 and 5 will get me this -1 that I need in the middle. So I think I'm going to do 4 and 1. That looks really promising to me. Again, don't be scared to just try. And if it doesn't work out, you can always go back and flip-flop things. Okay, so let's see. If I don't want to multiply the 4 and the 5, so I'm going to put the 5 in the middle here, so it gets multiplied by the 1, and then that leaves me a 1 over here. So I have a 4x squared and a 5x squared. And if I want -1, I'm going to make the 5 negative and the 1 positive. Okay, so here's what we've got. Since we have this equals 0 business, we can go back to that zero product property and say, okay, well then the only way this is possible is if the 4x squared minus 5 was equal to 0, or if the x squared plus 1 was equal to 0. And those give us two simpler equations. We now have two quadratic equations, which is hopefully very much in our comfort zone right now. With the 4x squared minus 5 equals 0, there's only a single x there, so let's use reverse order of operations. We can move the 5 to the other side, and then we can divide both sides by 4, and we get x squared equals 5/4, and then we can take the square root of both sides. Don't forget your plus or minus. This is quadratic. We're expecting that it's at least possible to get two solutions from that. And with square roots, the way you get the two solutions is with the plus or minus. I see that perfect square on the bottom, so I'm going to go ahead and just take the square root, and that's going to give me a 2. Okay, and then we have this other equation, and maybe you notice right away looking at that it's not actually possible to take a real number and square it, which gives you something that's definitely not negative, and then add 1 and then get 0 from that. And if you notice that right away, you can just cross that one out right now and say we don't get any solutions from that piece. If you don't notice it, you can move on. It's okay if you don't spot these things right away, because your algebra will tell you. So we'll get x squared equals -1, and then if you didn't spot it before, this is when I would expect you to spot it again. We get plus or minus the square root of -1, and that is not a real number. If you studied some imaginary numbers, that's great, but we are working exclusively with real numbers for this class, so that we would cross out and say, okay, this doesn't contribute any solutions. So I got 2 answers only. For a fourth degree, it's possible to get up to 4, but only 2 real answers for this one, and those are plus or minus √5/2. All right, for part B, before I jump in, I'm noticing that I'm missing something here. I'll fix it on your worksheet, but just for the video, there should be a 6 out in front right there. I'm looking again for that quadratic form, and I do see it. I have a 2/3 power and a 1/3 power, and that means that one is twice the other, so this quadratic form business should work on this. I'm also noticing that the 2/3, the bigger power, is going to be like my x squared term, and it has a negative coefficient, and that's generally a little tricky for factoring. So I'm going to move everything to the right-hand side, which means there will just be a 0 left on the left-hand side, and then we need to add the x to the 2/3. We need to subtract the 6x to the 1/3, And then the 5 is just hanging out. We haven't moved that, so it's still a plus 5. And you could, of course, write this in any order, but I'm trying to be kind of strategic to make it easier to see my factoring. So having those powers in descending order. So the squared one first, and then the variable that doesn't have the squared part, and then the constant. Okay, so again, I'm going to show the substitution on this one just to keep showing both methods. If I want to substitute here, what I'm going to substitute out is x to the 1/3, and that means that u squared is x to the 2/3. Sorry, that's kind of scrunched in there. So what we're going to get in here is a u squared minus a 6u plus a 5. So I have that really nice leading coefficient of 1, which makes the factoring a little easier. So I'm going to say split up the u's, and then I need factors of positive 5 that add up to negative 6. Not too many choices there, which makes this nice. So u has to have a minus 5 or a minus 1. Okay. And when I get it factored, it's actually really easy to spot the solutions. So we need u equals 5 or u equals 1. But remember, again, this is really important. If you do the substitution, we did not have any questions about what u was. Our question was about what x was. So you have to substitute your variable back. So I get x to the 1/3 equals 5 or x to the 1/3 equals 1. And to solve that, remember a 1/3 power is a cube root, so we're cubing both sides. So x equals 5 cubed, which is 125, or x equals 1 cubed, which is still 1. So those are our two solutions. Do be careful if you have an even root. So this was a cube root, so I don't have to worry about it. But if you had square roots or fourth roots in the mix, you would want to check and make sure you didn't have an extraneous solution. So that non-optional checking. Sometimes you can get an answer that doesn't actually work. And the same thing if you have negative powers. Just check and make sure you don't get any division by 0. Otherwise, you should be in good shape. So that's solving equations in quadratic form. And again, it ties back to what we've already done with trig functions. So hopefully this doesn't feel too crazy and messy. Thanks for watching.